Hello everyone. In this video, I want to show you how I used curves to control the feel of the character jump, and later in the video, I will show how I made the jump frame rate independent and making sure the character always reaches the max height of the jump. This is inspired from an Unreal stream. I will leave the link in the description below. I will also leave a link to GitHub repo where you can download this project. Start by creating a third-person C++ project and creating a class that inherits from character movement component. We have to tell our character to use the movement component that we just created. This can be done in the constructor of the character by using object initializers. There are other tutorials that shows how to use custom movement component in depth. I recommend watching them. After doing this, we should see that the character is using custom movement component that we created. If it doesn't show up on the character, don't worry. You will just have to click the compile on the character blueprint, and if that doesn't work, just restart the editor. Now that the initial setup is done, we can start working on overriding the default jump. Two things I did here. One, I created a curve float pointer that I can assign a curve to in the blueprint. And second, I overrided the DoJump function from the parent class. In the implementation of the DoJump function, I check if the jump curve is available. If it is, then follow the curve. If it isn't, then do the default jump. And as you can see, when the jump curve isn't assigned, it uses the default jump. And when it is assigned, it does nothing for now. Let's talk about how Unreal does its jump and what kind of movement modes there are. When you look at this code snippet, you can see that all it does is add velocity in vertical direction and set the movement mode to falling. There are a lot of different types of movement modes that Unreal gave us. Setting the movement mode to falling works for Unreal default jump because it uses physics and gravity. But for the purpose of this jump, I want to use a movement mode that is not affected by gravity, because character's positions will be defined by the curve. And so I set the movement mode to flying. First, let's make the character follow curve while ignoring the collisions. I'll be creating a couple of variables to track the jump. IsJump is true when the character is following the jump curve. Jump time is amount of time elapsed since the jump started. This is also used to get the height values from the curve. Previous jump curve value stores the curve value from the previous frame. This is used to calculate the delta height that character needs to move in current frame. Jump curve min and max time represents the bound of our curve in time axis, which is horizontal axis of the curve. Since horizontal bounds of the curve doesn't change, I'll be initializing jump curve min and max once in begin play, and initializing IsJump, jump time, and previous jump curve value variables in DoJump function. To follow the curve, override component tick function and do initial checks to see if we have everything for valid jump. Implementation is straightforward. Increment the jump time by delta time. Then get the value from the curve and subtract it from previous value to get the delta value. Setting the velocity in Z direction just in case if you want to use it in animations or somewhere. Then get the actor's location and add delta height that we got from the curve. Use moveComponent2 function to set the location. When jump time reaches the end of the curve, reset IsJumping to false and set movement mode to walking. I created a curve that looks like this. It goes to 300 in 0.3 seconds and comes back to 0 by 0.6 seconds. Then I pull the character camera out a bit so that it's easy to see the character and surroundings. And this is the result. It is following the curve, but the animations are all wrong. This is easy to fix since the animation blueprint is set up to play jump animation when character is falling, but we set our movement mode to flying. Overriding IsFalling function and adding additional check to see if our IsJumping variable is true will fix this. Another visual glitch is if you walk onto a platform and jump, the character does this visual animation glitch. This is because we set the character movement mode to walk, and when it can't find anything to walk on, it goes back to the falling mode. The character movement component class has this very handy function called find floor, and we can use that function to fix this glitch very easily. So what we do is we call the function and see if there is any floor to land on. If there is no floor, then we'll still be falling, and if there is floor, then we'll go back to walking. We do this check once we reach the end of our jumping curve. Now that we fixed all the visual glitches, let's move on to taking care of the collisions. Knowing that Unreal takes care of all the floor collisions, the only collision we have to take care about is the roof collision. And here is one of those places where we use the z component of the velocity that we already calculated earlier. If the character is moving up, then check for the roof collisions. For this, I created a collision query param object and added our own character to ignore. Then created a collision shape that is same as our character capsule. And use sweep single by profile to do a sweep test from our character's location to its destination location using the same collision profile as the capsule. If there is a blocking hit, then I stop jumping and set the movement mode to falling and let the gravity take care of the character movement. I used character's previous location as a safe location where there is no collisions, but this can be improved by using the hit results. And this is the result. At this point, I realized that there is a bug where character jumps only on alternative button press. It always misses one button press in between. This is fixed by adding call to reset jump state at every place where is jumping is set to false. I also added another check in DoJump function to see if the character is already jumping before initializing the variables. I observed that the character is taking more time to detect floor when jumping onto platforms that is higher than the character. This is because there is no detection for floor while falling. So whenever velocity is negative and after moving the capsule, I check for a floor. And when a floor is detected, I set the movement mode to walking and mark the jump as finished. When I jump from higher platform, character falling velocity doesn't match. I can clearly see the change in velocities when jump curve ends and gravity takes over. Easy fix for this would be to increase the gravity value in the character movement component until it looks good. But similar to jump, I want to be able to customize the falling of character using curves. That means instead of setting movement mode to falling and letting the gravity take over the character, we will handle all the falling logic. Similar to jump, we will create a variable to hold the falling curve. Is falling will be true when the character is falling. Falling time is amount of time character is falling, and previous fall curve value will hold the previous curve value. Now I initialize the isFalling value to false in begin play and also in DoJump function. Update isFalling function to account for isFalling boolean that we created. And create a function called setCustomFallingMode where we check if there is a fall curve, then initialize isFalling to true, fall time to 0, previous fall curve value to 0, and set the vertical velocity to 0 and set movement mode to flying. If the fall curve is not set, then set the movement mode to falling and let the default falling behavior to take over. Setting the vertical velocity to 0 is important because we don't want the velocity from jump to be carried over to falling since we want the curve to detect the velocity. Now replace all the function calls to set movement mode function with falling as input to our new function. We have to write the custom falling code in the tick and it's getting big, so it's time to do some cleaning up. I created two functions called process custom jump and process custom falling and moved all the jump code into process custom jump function and added the calls to both functions inside the tick. Implementation for custom falling is almost same as jump but without roof collisions. Add delta time to the fall time and get the value from the curve and subtract it from the previous value to get the delta value. Add the delta value to current actor location to get the destination's location. Now I can call findFloor function, but looking at the implementation of findFloor, I realized that it looks for floor in a very small distance. But based on how steep our curves are, character can be moving at least or more than 100 units in a frame if frame rate is low. and this will create a paper bullet problem. Find floor has a very handy fourth parameter that takes hit results. This means we can do our own trace tests and send the hit results to find floor, and it will use those hit results that we sent to find the floor. I also realized that I'm doing the same thing in jump when character is falling down. So instead of having same code in two places, I decided to move it into a function to reduce the clutter and improve readability. Final touch is to use our custom falling even when the character walks away from the edge of a platform. I observed that the character is jumping twice the distance of the curve. After some debugging, I realized that when in flying mode, the base character movement component will move the character based on the velocity. So the character is being moved 2 times, hence twice the distance traveled. We can change the character movement mode to custom, which prevents any interference from the base class. But this means that we have to handle input when the character is in air. I really don't want to go into handling input in this video, so I decided to nullify the vertical velocity to prevent this. But this means that you can't rely on vertical velocity in any part of the code. I placed markers at 300 and 600 units to test the height of the jump, and logging the total jump height. The jump height is almost perfect but not perfect and produces small errors. When I test the same by setting the max FPS to a lower value like 30 FPS, I observe that the error is much higher at lower FPS. This is good enough for a lot of games, but if you are making a platformer or want your character to jump exact height that you set in the curve, then we have to detect the apex of the curve and make sure that the character reaches the apex. When using curves, we can get range of values in both time and value axis and can get values at any given time. But if we want to know where in time does a particular value exist, that is not possible. So we have to make our own solution for it. Since the only value we care about is the apex, I have a solution that fixes this exact need. If we take any 2 points on the curve, let's call them P1 and P2, then P2 minus P1 would be a vector starting at P1 and going towards P2. And if we do a cross product between time axis and this vector, we get a normal vector. Interesting thing is that if both of our points are on the rising side of the curve, then the normals will be pointing towards the screen. And if they are on the falling side of the curve, the normals will be pointing away from the screen. This is how game engines detect back face during rendering. If normal is pointing towards the camera, it's the front face, and if it isn't, then it's the back face. So we take 3 points on the curve that are separated by a step size. Let's call them P1, P2 and P3 and get normals 1 and 2 from P2 minus P1 and P3 minus P2. If both normals 1 and 2 are facing the same side, then all 3 points are on the same side of the curve. We keep moving the points by step size until normal 1 is facing towards the screen and normal 2 is facing away from the screen. Once that is found, this means that we found the apex and it is somewhere in between P1 and P3. Keep reducing the step size and doing this again and again. Number of iterations and step size will depend on how close we want the time to be. Now, to convert this into code, I created a function. I decided to go for 5 iterations with step size of 0.1, which I later changed to 0.05. I get the range of time axis and generate the x values that are necessary to create P1, P2 and P3, running while loop for a set number of iterations and getting y values from the curve. I added a early out condition where if the value of the curve is apex height, then return the x value. I calculated normal 1 and 2 using the 3 points. I mistakenly did the cross product out of order, which I fixed later. Remember that the cross product is not commutative. As I talked before, I check if the normal 1 is positive and normal 2 is negative in z-axis. If yes, then apex is found. Otherwise, keep moving the points towards right at step size. Once the apex is found, reduce the iteration count and set start and end to P1 and P3 and reduce step size. I chose to half step size every iteration. You can use your own way of reducing step size. In case if you have a curve that looks like this, Since the curve is parallel to time axis during apex, z component of the normals will be 0. So I added a check to see if this is the case, then I consider that as apex. And when all iterations are done, then I take the midpoint between P1 and P3 as apex and return it. I use this function in begin play to get apex time and apex height and save them in variables. I use the isValidJump curve to check if the jump curve is valid and then use it. And in process custom jump function, after getting the jump curve value, when the jump curve reaches apex jump time, I set the jump height to the apex height instead of the value from the curve. I also added a call to notify jump apex function when character reaches apex to make sure that nothing breaks. This will make sure that the jump always reaches the apex height every time character jumps. If I play the game now and print the max height reached by the character, you can see that the character reaches apex height even at low FPS. I check the jump height at 120, 30 and 10 FPS and log the jump height. I will leave the link in the description where you can download the project and play with it yourself. Thanks for watching.